Mexico village, living on a pressure bomb. 11 mud vents open as a hydrothermal system expands. Imagine you are sitting in your living room in a quiet Mexican village. The normal sounds of life echo outside. Animals, distant voices, maybe a passing truck on a dusty road. Then, without warning, you hear a deep rumble from your own backyard. The windows vibrate, the air smells different, and when you run outside, the ground you thought you knew has turned into a monster. In the middle of your yard, the earth is boiling. Mud is flying into the air, steam is roaring like a jet engine, and a violent brown fountain is blasting out of a hole that did not exist the day before. Your animals panic, some are injured, and the yard is no longer a safe place. It looks like a small volcano has ripped open your property and is clawing its way to the surface. You try to tell yourself this has to be some kind of mistake, a freak accident, maybe a broken water pipe, or a failed septic system. But before anyone can truly understand what happened in that first yard, it happens again. Another property in the same village suddenly erupts, throwing boiling mud, steam, and gas into the open air. Whatever is going on is no longer a single weird hole. This is the reality facing the people of El Salitre, a village in Mexico that has suddenly found itself living on top of an expanding hydrothermal pressure system. Investigators move into the area, study the ground, and their findings change everything. They do not just see one vent or two. They count around 11 mud pools and vents across the same community, with several inside the original home and others on neighboring lands. The village is literally being perforated by new openings that spit out scalding mud and gas. The ground under homes is no longer something residents can take for granted. El Salitre is now living on what you could call a pressure bomb under their feet. And the terrifying question is simple: how far will this go? El Salitre does not sit in the middle of nowhere geologically. It lies in the state of Michoacan, a part of Mexico that already has a long history of volcanic and geothermal activity. Not far from the village is an area called Ixtlan de los Herbores, famous for its hot springs, steaming pools, sulfur smells, and old hydrothermal features. People travel there for spa-like hot water, tourist attractions, and the thrill of standing near the Earth's heat. In that tourist zone, bubbling water and steam rising from the ground are expected. Hotels and facilities are built specifically to take advantage of that natural energy. But El Salitre is different. It is a village of homes and stables, a place built on the assumption that the land underneath is solid and predictable. For years, the hydrothermal activity seemed confined to those known areas near Ixtlan de los Herbores. El Salitre sat nearby, but outside of the spotlight. That changed when the first violent mud eruption tore open a backyard. Suddenly, the line between tourist geothermal zone and village blurred in the most frightening way possible. The first major event happened near a house and a stable. The ground gave way, and a powerful jet of mud and steam exploded out, killing pigs and forcing residents to evacuate their animals. This was not a gentle bubbling hot spring. It was a raw, aggressive vent tearing through a family's property. People on the ground described it in simple words. It looked and sounded like a mix between a geyser and a volcano. Mud, steam, and gas shot upwards, turning a normal yard into something straight out of a disaster movie. And for the people watching it, one question rose above all others: what is happening beneath us? As the shock of the first event rippled through the village, some hoped it might be a once-in-a-lifetime freak occurrence. Maybe the Earth released some pressure, and that would be it. But the planet had other plans. Soon after, another incident struck. A second vent appeared on a different property in the same community. This was not a copy of the first event in the exact same spot. It was a new opening, a second backyard that suddenly became the mouth of an underground beast. With two separate sites erupting in a short period, the story changed. This was no longer a weird backyard hole situation. The pattern suggested a deeper cause, something that was not limited to a single fracture or isolated weak spot. People began to ask whether they were watching the birth of a new volcano. It is a natural question. You see hot mud, steam, and eruptions. You live in a volcanic region, and your mind goes straight to the word volcano. But the answer from experts who later arrived at El Salitre was more complicated than a simple yes or no. Initially, there was understandable confusion. The region is volcanic. The area has hydrothermal activity. The ground is certainly being heated from below. Yet, at the same time, the exact location, right inside the village, had never behaved like this before. The village found itself at the center of an unexpected and rapidly evolving geological story. Neighbors watched their land crack. People filmed the vents and posted the footage online. The world started to notice this small place with boiling yards and collapsing ground. When investigators and geoscientists finally arrived, they started with a critical question. Is this the birth of a new volcano? Their answer was clear, and, in a way, both comforting and unsettling. They said no, this is not a new magma volcano forming under El Salitre. In other words, there is no strong evidence right now that magma is pushing toward the surface beneath the village. They do not see the classic signs of magma rising, such as a clear swarm of volcanic tremors or lava nearing the surface at that specific location. That means we are not talking about lava fountains erupting in the middle of town. But then they added the part that matters just as much. What is happening is a hydrothermal mud system, and it is active directly beneath this community. A hydrothermal system is not a calm, harmless thing. It is a network of hot underground fluids, water, vapor, gases, and mud, moving through the rock under pressure. Those fluids are heated from below, often by magma deep underground or very hot rock that still holds the energy of past volcanic activity. In this case, experts emphasize that magma is not currently erupting here, but something at depth is absolutely heating these fluids. You can think of it as a buried heat engine, pushing hot water, steam, and gases through fractures. As those fluids rise, they look for paths of least resistance. If the cracks in the rock line up under a village, then the vents will appear in that village. That is exactly what appears to be happening in El Salitre right now. So while this is not the birth of a classic cone-shaped volcano, it is still a sign that the underground plumbing is changing. And when underground plumbing is made of hot pressurized fluids, those changes can be fast and dangerous. The full scope of the problem only became clear when investigators began mapping the vents. They realized that the first dramatic backyard eruption was only one piece of a larger pattern. In total, they reported finding around 11 mud pools or vents in the area. Roughly 3 of these were located on the original property where the first eruption took place. The remaining 8 were found on neighboring lands nearby. This was not localized damage to a single unlucky household. It was a cluster of active features scattered through a section of the village. 11 is a crucial number here. 1 vent can be explained away as an odd local event. 2 start to look like a trend. 11 vents, spread out over multiple properties, show that the system beneath El Salitre is bigger than any 1 yard. Temperature measurements taken at some of these vents showed values close to 86 degrees Celsius, or about 187 degrees Fahrenheit. That is almost boiling. At those temperatures, water and mud can cause severe burns in seconds. Falling into or even stepping into a shallow hot pool can be life-threatening. The danger goes beyond what you can see at the surface. Around vents like these, the ground can be hollowed out underneath, forming pockets and weak zones where hot fluids have washed out material. From above, the soil might look firm and safe, but underneath it could be thin and unsupported, like a fragile crust over a hidden cavity. Videos show residents standing very close to the edges of some of these openings, leaning in to look at the bubbling mud and steam. From a distance, it may look like harmless curiosity. Up close, it is terrifying, because the real danger zone extends beyond the visible rim of the vent. That solid ring of earth around the hole might be the part that collapses without warning. This is why authorities and experts have warned people not to go near the vents, not to walk on hot, cracked, or unusually wet ground, and to keep children and animals away from the affected areas. The hazard is not just the dramatic hole, but the entire weakened zone around it. To understand why this is happening specifically in El Salitre, we have to step back and look at the local geology. The village is close to Ixtlan de los Hervores, a well-known geothermal area with hot springs, sulfur-rich gases, and hydrothermal tourism. That alone tells us the region has heat and fluids at depth. But El Salitre itself also sits on the Ixtlan Fault, a structural weakness in the Earth's crust that acts like a natural pipeline for hot fluids to move upward. Faults are cracks where rock has slipped and broken. They can conduct water and gases from deep underground to shallower levels. In volcanic and geothermal regions, they often become the main highways for hydrothermal systems. In simple terms, the Ixtlan Fault beneath El Salitre is an open door. For years, that door might have been half closed or blocked by rock and sediment. But now, it appears that something in the pressure system has changed, and more hot fluids are using that pathway to reach the surface. The strange part is not that geothermal fluids exist in the area. They have been present for a long time. The strange part is that these fluids are suddenly appearing in places they never did before, like backyards and farm plots in El Salitre. The hydrothermal system is, in a sense, expanding its footprint. Maybe pressure has increased. Maybe older pathways near the traditional geothermal center have partially closed, forcing the system to seek new outlets. Maybe small earthquakes or subtle shifts in stress along the fault opened fresh fractures. Whatever the exact cause, the result is visible. Vents in the village. This is what makes the situation so unsettling for residents. They are not just near a geothermal zone anymore. They are inside it. The boundary between danger zone and home is being redrawn in real time beneath their feet. At the heart of this crisis is a simple physical reality: pressure. The underground system beneath El Salitre is made of hot water, steam, gases, and mud moving through a network of fractures and porous layers. These fluids are under pressure, like a shaken soda bottle, but with far higher stakes. When pressure builds up and there is no easy way out, it creates stress on the surrounding rock and soil. If a new crack forms, if an old well provides a path, or if a weak zone gives way, that pressure will exploit it instantly. That is how a calm backyard can turn into a roaring vent in a matter of minutes. One of the newly opened vents may have used an old water well as a conduit. The well did not create the heat, but it gave the pressurized fluids a vertical channel to reach the surface. Once that happens, the ground around the well can rapidly destabilize. Hydrothermal systems like this do not only erode downward. As fluids flow, they can carve sideways as well, expanding their pathways, changing direction, and undermining the ground above. Over time, this can create underground networks that reach beyond the visible vents. This is why authorities are worried about hidden hazards. The visible vents are just the parts of the system where the pressure has already broken through. There may be a much broader network of heated, weakened ground that has not yet opened, but could in the future. The risk is not that every square meter of the village will explode, but that nobody can be fully sure which part of the ground will fail next. In a community where people walk, work, and play on that ground every day, that uncertainty itself becomes a threat. Whenever something like this happens in a volcanic region, people immediately fear a larger volcanic eruption. So could this escalate from hydrothermal vents to a classic volcano eruption in El Salitre? Scientists watching the situation say there are currently no signs that magma is actively rising toward the surface beneath the village. They are not seeing evidence of a developing magma chamber right under the homes. For now, that possibility appears low. However, that does not mean the situation is safe or minor. Hydrothermal systems can be extremely dangerous, even when magma stays deep below. They are controlled by pressure, and pressure can change much faster than deeper magmatic processes. If vents become blocked, if water suddenly flashes to steam in a confined space, or if a cap of rock holds back rising fluids until it fails, hydrothermal explosions can occur. Such blasts can throw rocks, mud, and boiling water with little warning. They are smaller than major volcanic eruptions, but can be deadly on a local scale. In El Salitre, the realistic near-term danger is less about molten rock and more about unstable ground, scalding fluids, toxic gases, and the spread of vents into more of the village. The system does not need to become a magma volcano to turn parts of this community into a no-go zone. The worst realistic scenario in the short to medium term is one where more vents open, more ground collapses, and authorities are forced to evacuate larger areas. Homes could become uninhabitable, not because they are buried in ash, but because the land beneath them is unreliable and sometimes boiling. So what exactly could daily life look like in El Salitre if this continues or intensifies? Imagine waking up every morning wondering if a new crack has appeared near your doorway. You check your yard, not just for weather or weeds, but for steam, soft patches, and fresh mud. More backyard vents could open in the coming weeks or months if the pressure system keeps searching for outlets. The ground around existing vents might weaken further, leading to small collapses or sinkholes. Patios, walkways, and parts of streets could start sagging as the support beneath them erodes. Inside the village, there is also the risk of gas accumulation. Hydrothermal systems often release gases like carbon dioxide and hydrogen sulfide. In open air, these might disperse quickly, but in low-lying areas, basements, or poorly ventilated rooms, they can build up quietly. Residents might notice strong sulfur smells, burning eyes, or headaches before they realize something is wrong. Children, pets, and older people could be especially vulnerable. If authorities do not move quickly to monitor gas levels, unseen pockets of dangerous air could form in the very spaces where people seek shelter. In a worst realistic scenario, parts of El Salitre might have to be cleared out entirely. Houses near clusters of vents could be condemned or left empty. Families would be forced to relocate, not because their homes were destroyed by a sudden catastrophe, but because the slow, relentless reshaping of the ground made staying too risky. For a small village, that kind of disruption is massive. Livelihoods tied to land and animals are suddenly uncertain. Property loses its value. The place that was home starts to feel like a trap. The people of El Salitre are not helpless, but their options depend heavily on how quickly and seriously the authorities respond. Local officials have already begun warning residents to stay away from vents and to avoid walking on hot, cracked, or wet ground. That is the first and most urgent step. Keep people physically away from the obvious danger zones. From there, systematic monitoring becomes essential. Experts need to measure temperatures at the vents regularly, track changes in mud discharge, and sample the gases being released. If new vents appear, they need to be documented and mapped. Mapping the hazard is not just academic. By drawing out where vents are, where the ground is hot, and where cracks are forming, authorities can identify zones that are too risky to inhabit. Those maps then guide evacuation decisions, land use restrictions, and emergency planning. Communication with the public is just as important as the science. Residents need clear, simple explanations in everyday language about what is happening and why. They need to understand that even though this is not a lava volcano, it is still a serious hydrothermal crisis that demands caution and respect. In a best-case scenario, the hydrothermal system might stabilize after releasing enough pressure through the existing vents. In that case, the village could slowly adapt, perhaps living with a known set of hazards that are fenced off and closely watched. In a worse scenario, the system could continue to evolve, forcing long-term or permanent relocation from parts of El Salitre. There is also a lesson here for other communities in volcanic and geothermal regions around the world. Living near hot springs or volcanic fields is not just about spectacular scenery or tourist income. It is about understanding that the ground beneath you is part of a larger system that can change, sometimes suddenly. El Salitre's story is still unfolding, but one reality is already inescapable. This small village is now living directly on top of an active, expanding hydrothermal system. 11 vents have already opened, with scalding mud and steam carving their way upward through homes and fields. Experts say this is not a new magma volcano, yet they also make it clear that this is not normal for this location. The ground is opening where it never has before. The hydrothermal activity that once stayed at a distance has crossed an invisible line and moved into living space. For the families of El Salitre, this is not just a geological curiosity or a viral video subject. It is a daily, personal crisis. Every new crack in the ground is a question mark. Every hiss of steam is a new worry. The earth beneath them is speaking in the language of pressure, heat, and fractures, and the village has no choice but to listen. In the end, this is not just a story about rocks and fluids. It is a story about people adapting to a suddenly unstable world under their feet. The coming months will decide what happens next. Will the system calm down and settle into a new, uneasy balance that the village can live with? Or will more vents open, more homes be threatened, and more families forced to leave the land they thought would always be solid? Right now, El Salitre is living on a pressure bomb made of boiling mud, steam, and gas. It has already opened 11 vents, and somewhere below, the system is still adjusting, still looking for the next weak spot. If you found yourself in this village, with the ground literally breaking open around you, would you stay and hope the earth calms down, or would you walk away before the next vent erupts beneath your feet?